This video explains checkpoint recovery, focusing on how it reduces recovery time in database systems. Recovery is needed because database systems must ensure data durability despite system crashes like power failures or hardware issues, transaction failures caused by logical errors or deadlocks, and media failures, such as disk corruptions or storage failures. The challenges in recovery include ensuring atomicity of transactions, maintaining consistency after failures, minimizing recovery time, and reducing performance overhead. A basic recovery mechanism involves log-based recovery. The database maintains a log of all operations. Each log entry contains information to undo or redo operations. During recovery, the system uses the log to restore consistency. Here is a typical log entry structure. It contains transaction ID, the operation which could be update, commit, or abort. It also contains the page ID for update operations, the old value that is before image, and the new value that is after image. After a system crash, a naive recovery approach requires scanning the entire log from the beginning to identify transactions that need to be undone and redo committed transactions that were not written to disk. The problem with this approach is that as the system runs longer, the log grows indefinitely, and the recovery time becomes proportional to the log size. This slide shows the log growth over time. If the log is small, the recovery time will be less, but if the log is large, then the recovery time will be more. So recovery time increases linearly with log size. A checkpoint is a mechanism that marks a point in the transaction log where the database is in a consistent state, all modified data has been written to disk, and recovery only needs to consider transactions after this point. Periodically create checkpoints to limit how far back recovery must scan. Checkpoints significantly reduce recovery time, allow old log records to be archived or discarded, provide a known good state to recover from, and improves overall system availability. When a checkpoint occurs, the transaction processing is temporarily suspended, all modified buffers are forced to disk, a checkpoint record is written to the log, and normal processing resumes. In this pseudocode for checkpoint operation, first suspend new transactions, then wait for active transactions to complete, after that flush the buffers and write to log mentioning checkpoint, and finally resume transaction processing. During recovery, only transactions that were active at the checkpoint or started after need to be considered. On this slide, the topmost bar represents transaction 1, the middle bar represents transaction 2, and the bottom bar represents transaction 3. The checkpoint marker shows where the checkpoint was taken. The recovery algorithm involves finding the most recent checkpoint record in the log, identifying transactions that were active at the checkpoint, scanning forward from the checkpoint to find all transactions that started after the checkpoint, redoing all committed transactions, and undoing all uncommitted transactions. Here is a log entries example, where after a system crash, we need to redo committed transaction T1 and undo uncommitted transactions T2 and T3. There are several types of checkpoints, including fuzzy checkpoints, which allow transactions to continue during the checkpoint, reducing system pause time but requiring more complex recovery. Incremental checkpoints, which only flush modified pages since the last checkpoint, spreading I/O cost over time. Partial checkpoints, which checkpoint only specific parts of the database, useful for very large databases. The frequency of checkpoints needs to be considered as well because if it is too frequent, there will be high overhead and it will impact performance. If it is too infrequent, there will be a longer recovery time after failure. The optimal frequency depends on transaction volume, system resources, and recovery time objectives. In summary, checkpoints significantly reduce recovery time. Different checkpoint techniques balance performance versus recovery speed. Proper checkpoint frequency is crucial for optimal system performance. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.